the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. Now, this video you're about to see is one of my older videos. The quality is not the same as my new video series. My intent is to make a newer version of this video at some point in the future. However, I want to make sure that students currently using my Mathematics in Review video series have access to as much help as possible when it comes to prerequisite topics. With that being said, let's get started.
There's a lot of different kinds of equations out there. I mean, tons of different kinds of equations. In fact, I could just write a few down here. So examples, these are all going to be equations. You've seen some examples I've written down before, like 3x plus 1 is equal to 7. That's an equation. X squared plus 5x plus 6 is equal to 0. The square root of x minus 3 is equal to 10. That's an equation. X over x plus 1 is equal to 5. That's an equation. So we have a bunch of different equations here. But each of these equations are very specific on how you would solve them, how you would approach them. And so we like to label these, give these names. We like to, in mathematics, we like to box things up. And one of these, specifically this one, is the one we're going to start off with. That's a linear equation in one variable. A linear equation in one variable is an equation of the form ax plus b is equal to c. And often, most mathematicians even leave off the c, and they'll just write that as ax plus b is equal to 0. The reason why is because if you just consider for a moment as an aside, 3x plus 1 is equal to 7, I could rewrite that by subtracting 7 from both sides as 3x minus 6 is equal to 0. And there you see that's an ax plus b is equal to 0 form from the fact that we started with an ax plus b equals c form. So a linear equation in one variable is defined to be an equation of the form ax plus b equals c, where a, b, and c are constants, and suppose a is not equal to 0. Main reason why this last condition is on here, by the way, is that if a is equal to 0, just pretend it is for a moment, then you don't have any variables, because 0 times x would make that term disappear. You would just have some constant equals a constant. There's no variable there. That's why to be a linear equation in one variable, we need that variable to survive. And again, that 3x plus 1 equals 7 is an example of a linear equation in one variable. This second one is not, because it's not an x, it's an x squared that you have in there. This is not because it's the square root of x. This is not because you have a fraction with x's in it. So x is specifically in the denominator. And we'll approach kind of how to solve stuff like that later on in the course. And you'll see that the technique that I use to solve equations, I generally only like one technique to solve every equation I could possibly do until I get to more general equations. So I'm going to stick to a favorite form of mine to solve equations. Let's go ahead and solve this equation right here. Now, the first thing you want to do whenever you go to solve an equation, so maybe I should just write a little method here, even though I'm not a big fan of methods, but I do want you to know that there is a technique to solving equations. The first thing I generally do is clean up each side. What that means, at this point in mathematics, you should already know this, is essentially make sure you have no parentheses, no grouping symbols. You combine like terms. So on each side, that's what we're going to do. This would imply, and by the way, in your math instructor would be very impressed if you stick with this notation. This equation is not equal to another equation. It's not like that. You have an equation and you do some work to make it an equivalent equation. So this implies that little arrow means implies that 3x minus 2x minus 2 is equal to a negative 2x plus 4, which implies, when we combine like terms on the left hand side, 3x minus a 2x is a single x. So we get that far. So we've cleaned up both sides. There's no grouping terms, all like terms have been combined. The second thing I do, now that I've done that, and I can't go any further, is I get all my variables on one side and all my constants on the other. In fact, it's better said just get all your variable terms on one side. So I look at this equation, I think to myself, well, what would be better? Would it be better to get this single little x over to the other side by subtracting x from both sides? Or would it be better to add 2x to both sides? I like to keep things positive, so what I'm going to do is go ahead and add 2x to both sides. So on the left hand side we now have 3x minus 2. On the right hand side we just have a nice little 4. And I am assuming that you know all these operations with equations. And I know I'm taking my time here, but I need you to kind of see my thought process. At this point, I take a look at this. I know how to solve this equation, so you should make a little note here though. If there's only one version of your variable in that entire equation, then you can untie the knot. And this is where a lot of students hate my method initially, but then love it in the long run. It's because students at this point know what to do with this equation. They know they add 2, divide by 3. Okay, great. But I want to show you kind of a method that will be extremely useful for future topics in mathematics. The idea of an equation is that somebody grabbed that x, and instead of telling you exactly what it was, in this case x is going to be 2, I know that, but instead of telling you, oh, by the way, x is 2, they've tied it up in a knot. They've essentially attached to it a 3 and then subtracted 2 from that. So they've hidden the value of x from you by doing that to it. So what you need to do is untie it. Now, you can think of that as somebody tying a knot, that they had x and then they started tying it up with a 3 on it and then tied it even to a knot even further by subtracting 2 from that. So what I do is I list out what happened to x. I know that most people already know how to solve this and they want to just skip this, but I'm telling you, very, very important to just think of it this way, because there are going to be a lot of topics in an intermediate algebra course, trig course, pre-calculus course that's going to rely upon something called the inverse. And that's a very advanced mathematical concept. If you start viewing mathematics the way I'm teaching it right now, you will, in the long run, benefit. Once you reach inverses, you'll be like, oh, I totally know what that does. It's just you're untying the knot. That's all an inverse does. All right, so what happened to x? Well, somebody took x and they multiplied it by 3. And then after they multiplied it by 3, they subtracted 2. Order of operations, right? And this is what I like about saying it this way, is because you're following the order of operations. If I just went straight to solving this and saying, oh, I add 2 to both sides, divide by 3, it's counterintuitive because you are not following the order of operations. The order of operations says do anything with addition or subtraction last. I like to stick with one thought process throughout an entire course if I can, and my thought process is the order of operations. Well, somebody had to follow the order of operations to hide this x from you, so what they did is they multiplied it by 3 and then they subtracted 2. Now we're going to untie this. So this is how they made the knot. Now we're going to untie. And when you think of a knot, when you untie a knot, the thing you untie is the last thing that's been tied. So the last thing that was tied was step 2. That's the last thing they did, right? So to undo a subtraction of 2, we're going to add 2. Once we're done untying that, we'll hop up this ladder here. To untie this multiplication by 3, we do the inverse of multiplication by 3, which is division by 3. This is my roadmap to untying this knot. I'm going to add 2 to both sides to get 3x is equal to 6. And then I'm going to divide both sides by 3 to get x is equal to 2. I know it's extremely lengthy to say out loud, to go through and do all that, but the fact is this will help with tons of equations in the future. Radical equations, some rational equations, logarithmic equations, exponential equations, stuff that you haven't seen yet, trigonometric equations, some equations in pre-calculus, solving some calculus problems. It's all throughout that. If you follow this method, as long as you have this satisfied, that there's only one version of your variable, you can do that. And often that's the case in mathematics. Now, not all the time, but it can be the case. Now, in the last example, we spent quite a bit of time going through it, and I still think it's very beneficial to have gone through all that. But the fact is that we still need we need to speed up a little bit, right? So let's go ahead and tackle this next example. First of all, first step is always to clean up sides. And you can see that both sides are cleaned up. There's nothing really you can't combine like terms on the left side, and there's nothing to do on the right hand side. So the second thing we do is move variable terms to one side, so isolate, I guess you could say, variables. It's not completely isolated actually. I'm just gonna decide to move all my variable terms to one side. I can move them all to the right hand side. Yes, I could do that. I tend to not do that actually out of habit, but you could totally do that. You can subtract 2.4 from x from both sides if you want. I'm going to just keep my habit of keeping my variables positive, so I'm going to add 3.7x to both sides. Not necessary though. You could have done it the other way, and most people would have. I just have this habit of going about it this way. On the right hand side, you see that the 3.7x's will cancel. On the left-hand side, what do I get? 6.1x plus 8.1. By the way, you'll often hear me just do math in language, or 6.1, that type of thing. Okay, and at this point, I want to untie. I see I have one version of my variable, so I'm going to start the untying process. So I ask myself, what happened to x? What did somebody do to x to tie it up like this? Because they obviously didn't tell me what x was. The first thing it looks like they did is they multiplied it by 6.1. The second thing it looks like they did is they've added to it by 8.1. So I'm going to untie that by untying the last thing they did, that knot, say I tied x up in a knot, by subtracting 8.1, doing the inverse of addition. And then after I'm done undoing that addition, I'll undo multiplication, which is division, dividing by 6.1. Now here I go. I'll subtract 8.1 from both sides to get 6.1x is equal to a negative 8.1. And then finally, to untie this last little bit, I'll divide both sides by 6.1. And this will give me x is equal to a negative 8.1 over 6.1. Now you don't want to leave a fraction with decimals in it. I'll often say this anyway, but I just want you to make sure that you do not stop here, because this would be absolutely horrible notation. So grab a calculator and figure out what this is. Let's see. So I boot up my calculator here. It's negative, 8.1 divided by 6.1. Remember, your calculator has a special negative button, so don't use a minus sign for negatives. Hit enter, and you get some decimal approximation. Let's go ahead and round this to the nearest hundredth. So we'll have a negative 1.33, right? That 7 rounds that 2 up. So negative 1.33. And a little word to the wise here. When you're doing this, it's roughly equal to a negative 1.33. It's not exactly equal to it. So it's very important that you let people know it's roughly equal to a negative 1.33.
Thank you for watching this review video. As I mentioned previously, it's an older video that will eventually be updated. However, it should get the job done for you. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you review any prerequisite material mentioned in the video. If you find you're continually having to research the prereq material here, you might want to consider speaking to your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.